Okay, so today we're going to talk a little bit about section 3.2 homework. This is all about solving quadratic equations in a number of different ways. So we're going to jump right into it. So we've already talked about quadratic equations and what they look like. They have the x squared here. And in general, you're going to want to make them look like this. We call this descending order, where we have the biggest power of x first, and then we kind of descend from there, x to the first, and then a constant term. And then standard form means we have a zero on one side. We have all of our terms on the left side in descending order. That gives us standard form, and that's what we're looking for just about all of the strategies that we're going to do. Now, a few of these questions in my math lab will ask you to use a specific strategy, like this one might say to factor, but honestly, I don't really care what method that you use. I'm going to show you a couple of options here. If you want to solve it by hand, there's a couple of choices there. You can also use the technology. I want you to be able to get the solutions to this. Some of you will remember some factoring from previous courses, and if so, then that's probably the quickest way to do problems like this. But if you don't remember your factoring very well, or you're not comfortable with your factoring, that's okay. We can use the technology in its place. So I'm going to solve this one by factoring first, and then I'll show you how to do it in the calculator as well. And you can just use the method that works the best for you. So looking at this problem, if I'm going to solve it by factoring, the first thing that I'm looking for is, what goes into all of my terms. I'm looking for a greatest common factor, and we do have one here. All of those terms, GCF is what we're looking for there. And all three of those terms are divisible by 7. So that's going to be my first step here, is to take that 7 and pull it out to the front, and then just divide each term by 7 to see what's left here. So 7 divided by 7 is 1. So we've just got x squared there. 42 divided by 7 is 6. And then 112 divided by 7 is 16. Okay, and so we've got a much simpler expression inside this parenthesis here to work with. Okay, and now we're going to continue factoring. So if I'm looking at these three terms and I want to factor it, I'm going to set up a little x. Of course, there's a million different ways to organize your factoring. I like to think about it as an x. So what I'm going to look for are two numbers that multiply to give me -16, this number on the end, and add to give me -6. So -16 is my product and -6 is my sum. So thinking about ways to do that, I know that when I multiply to get a negative number, one has to be negative, one has to be positive. So I'm really going to be subtracting those numbers. 8 times 2 is 16. 8 minus 2 is 6. So that's perfect. Okay. And then I know I want them to add to give me a negative number. My signs have to be different here. So the bigger one's got to be negative. So -8 and +2 are my values there. Okay. So my next step then is to break this down into two sets of parentheses. X squared is like x times x, so we can put those in there. And then the -8 and the -2, or sorry, the -8 and the +2 from my work over here will go right into those parentheses. Okay. Last step is to take each of our factors here and set them equal to 0 separately. Don't have to worry about the 7. It doesn't have a variable in it. So I'm just going to focus on the two that have variables in them. So x minus 8 equals 0 will give me that x is 8. That'll be my first solution. And x plus 2 equals 0 will give me that x is -2. And that'll be my second solution. Okay, so there's my answers by factoring. Okay. Now, that's one option for how to solve this problem. If you'd prefer to use the calculator and the technology to help us out, we can do that as well. Let me show you how that would work. So what I'm going to do is I'm just going to go into y equals, clear out any expression that I have in there, and I'm just going to type it in. So 7x squared minus 42x minus 112. Okay. And then I'm just going to set up a standard window here. So choose zoom 6, which is zoom standard. Okay, sometimes you might have to adjust this a little bit, and you'll notice this does look a little strange. And that's because of this -112 over here. So if I wanted to play with it a little more, I would have to adjust my window, but I really don't have to. I'm really looking for these 2 points. Okay. Maybe I will adjust my window a little bit, try to make it a little better here. So let's go down to like, I want to go down below this value. So Well, still not far enough. So we can go down a little more. Again, when you're setting a window in a calculator, it's not an exact science. It's more of an art. It's more of a trial and error kind of thing. So don't get frustrated if your window doesn't do exactly what you want the first time. Just kind of keep playing with it. We need to go down further. So I'm going to keep adjusting down my Y min. That's the bottom of the graph. Okay, and so now we can see the whole thing. So finally, we're just going to find these two x-intercepts. Those are the points we're looking for because we're trying to find where this graph is equal to 0 over here. So calculator's good at that. We're just going to hit second trace, choose the 0 option here, and then we're going to take our cursor, we're going to scroll it over somewhere that's definitely to the left of that. Okay, and then we'll scroll over somewhere to the right of that and then hit enter again for our guess, and we'll get -2 for our first one, just like we had before. Do the same thing again, second trace, 0. We'll have to move our cursor over here. Again, we could really hit enter right now if we wanted. We want to make sure we're to the left of it, and we are at this point. So we'll just hit enter there and then scroll over somewhere that's definitely past it on the other side, hit enter again, and then the guess will give us that 8 that we're looking for. So some options for how to solve this problem. If you want to solve it by factoring, that's fine. That's one option. If you want to solve it in your calculator, that's fine also. If you're more comfortable with the quadratic formula, you could also solve this problem with the quadratic formula as well. We'll do one of those in the next problem as a review. But really, we have 3 options for how to solve this problem. I don't really care which option that you choose, right? I just want you to get the correct answer for these things. Okay, so there's another type of problem, one that I've listed here that's a little different. This is one where we're really not going to have any options for how to solve it because the instructions tell us to solve this particular quadratic equation using the quadratic formula and to give an exact answer. Now, what the calculator will not do for you is it won't give you exact answers with radicals in them. So this is one where we don't have very much choice at all as to how to solve it. So we're really going to have to do this one by hand. We'll have to do this one with the quadratic formula, or else we won't be able to get the exact answer that we're looking for here. Okay, so let's talk about how to do that. So the first step is just like the first step in the last one. We want to get it into standard form. We do have that. All of our terms are on the left side, and we have descending order. Okay, so the next step is to plug our values into the quadratic formula. It looks like this: x equals minus b plus or minus square root b squared minus 4ac all over 2a. So if I think about what my values are here, my a is this coefficient, nothing written there, so we know it's an implied 1. Our b is 3, and our c is -6. Okay, so we'll plug in to our equation here. So we want the opposite of b, so the opposite of 3 is -3. b squared, 3 squared, minus 4 times a is 1 times c is -6 all over 2a. So 2 times 1 there. So working this out, I'm just going to do this entire calculation here. So this is like 9 plus 24. So that's 33. Okay, we want to try to simplify if we can. We're not going to really focus too much on how to simplify radicals in this class. It's more of a something for another class that's more science-based. So I think that most of the time with these kind of questions, if you're asked for an exact value, you won't have to do any radical simplifying. We don't here. So we're just done. This is our answer. And, it might look like one, but really there's 2 separate answers here. Remember, this plus or minus means -3 plus the square root of 33 divided by 2 and -3 minus the square root of 33 divided by 2. So we get the 2 answers that we want here. That's what we're looking for. You want to pay attention to the instructions on problems like this. Because it might ask you to use a comma to separate the answer. So if you needed to do that for MyMathLab purposes, then what you would do is you would type the -3 plus the square root of 33 over 2, comma, -3 minus the square root of 33 over 2. So because of the way the instructions are worded, that's what we need to do to finish up. Okay, so we'll also have a few application problems in these sections where we're going to use some of these ideas with these quadratic equations. So this one says a ball may be thrown, a ball is thrown upwards. Its height can be modeled by the equation S equals 12 plus 96t minus 16t squared feet, where t is the number of seconds after the ball is thrown. When will the ball be at a height of 120 feet? Okay, so the first thing we want to think about here is what happens when we throw a ball in the air. And, you know, we've all seen that. It goes up for a while, then it comes back down. And in fact, you know, if you ignore air resistance, this is what happens. You can use a quadratic model to approximate what's going to happen with anything that you throw up in the air. It'll go up for a while, it'll peak, and then come back down, right? Quadratic equation. Okay, and if we're thinking about this, we're trying to find out when this thing hits 120 feet, right? And so the most common thing that will happen for situations like this is it'll hit it once on the way up and it'll hit it again on the way back down. So I'm expecting to get two answers for this problem, okay? So the first thing I want to do is I want to set up my equation, and I'm really going to use the calculator for everything here. Okay, so I'm going to go ahead and go into y equals. I'm going to clear out whatever's in there before. Okay, I'm going to type my first equation, 12 plus 96x minus 16x squared, and y1. And then I'm going to draw this horizontal line like I did here in this example by just putting a 120 here in y2. Okay, and then if I can find the spot where those two graphs cross, we're in good shape. Now, I do need to set my window here, okay? And what I can use to help me in this one, since it's a word problem, is I can use my experience from the real world to help me out. Like, we're throwing a ball up into the air, right? And so we don't care about what happens before we throw the ball. So x min is definitely going to be 0, okay? And then x max, how long does a ball stay in the air when you throw it up there? And not too terribly long, right? So I'm going to guess no more than maybe 20 seconds. I mean, 10 is probably fine. And then since I've given it X values that I want to work with, I'm not even going to try to set the Y's. I'm going to let the calculator do that for me. I'm just going to go into Zoom and choose Zoom Fit. Zoom Fit option here is going to say, okay, I gave you the good X's. You pick Y's that go with those X's. Okay, so if I do that, and it looks like 20 is too big. Again, this is something that you can't get frustrated with. Sometimes you're going to set your window and it's going to be a little bit off. Like I said, maybe 10 makes more sense here. So I'm just going to come in here and adjust it again. You're not going to get it right the first time every time. That's all right. Just go 0 to 10 and then do the Zoom Fit again. And even better, but looks like it's still too big. But I mean, really, we can see what we want there. We can see the points where this graph crosses. So I might adjust it down just a little bit more just to make it a little easier to work with. So maybe 0 to 7 and then do Zoom Fit. Okay, again, I just see too much over there. And then we get a model that's a little nicer to work with here. Okay, so again, you're just not going to get your window right the first time. Like I've done this for years and I still don't get the window right the first time every time, right? So the key thing to remember is it's just part of the process. You just have to kind of work backwards, adjust those windows. You'll have to try a few times to get it right. But once you do, you'll get an equation like this that is good for our purposes. And then what we're trying to do is we're trying to find these 2 points where our 2 graphs cross. So to do that, we'll just choose second trace. Okay, and then we'll choose the intersect option here. Okay, we'll follow the instructions down below. We've got y1 selected for our first curve, y2 selected for our second curve, and then it'll ask us for a guess. I'll just go somewhere over in the vicinity of this first one right here. And so it looks my first one is t is equal to 1.5. Okay, and then we can do the same thing to find that second one. So second trace, choose intersect here, enter for the 2 curves. And now I'm just going to take my cursor over here that's near to the second point. And so 4.5 is going to be my second point there. Now, what are these values? Well, they're t values. T is the number of seconds after the ball is thrown. So this is 1.5 seconds and 4.5 seconds. That's when we'll reach those heights. Okay, so let's take a look at one more application problem. This one says the revenue function for our product is R equals 690x, and the cost function is 18,000 plus 60x plus x squared. We want to form a profit function and then determine how many units must be sold in order to break even on this product. Okay, so the first thing that we are asked to do here is to find the profit for this particular product, and the profit functions are always calculated by just doing the revenue, the amount you bring in, minus the cost, the amount you send out. Okay, so that's going to be our first step. We're going to get a P of X by taking our revenue function, which was 690x, minus our cost function. One thing that's important is when you're subtracting expressions like this, you do need to make sure you put them, I should probably just put them both in parentheses. First parenthesis doesn't really matter here, but the second parenthesis is going to matter very much if we want to get it set up correctly. Because we're going to want to combine like terms here. And before we can do that, we need to get rid of this parenthesis. So this is like a -1 here that we need to distribute to all of our terms. It's going to change all of our signs, basically. So we've got 690x minus 18,000 minus 60x minus x squared. And then finally, we've got a couple of like terms here that we can put together. So we'll subtract those. We'll get positive 630. Okay. And so there's my profit equation. So again, we're going to get that profit equation by doing the revenue equation minus the cost equation. Make sure you put the parentheses around, especially the cost function, because we're going to need to distribute across the parentheses to get that set up. Okay, so the next question asks me to determine how many units must be sold in order to break even on this product. Okay, so the break even point is the point where our profit is equal to 0. So we're going to put a 0 in over here. And so we've got a couple of choices again. If we want to, we could certainly use the quadratic formula and do this by hand. Numbers are kind of big. So to me, this is just a problem that we're going to use the technology to solve. So again, kind of the same approach as the last one. I'm going to start by going into y equals. I'm going to clear out everything that's in my list previously. Okay, and then I'm just going to type my function in here. Okay, and then I'm going to set my window. Now, this one is very tricky to set your window because it doesn't really tell us what we're producing, right, at all. So this is one where we'll certainly have to do some trial and error. So, the cost for producing 0 goods is quite high. So I'm guessing we're not producing like a ridiculous number. I might start at like 50. Again, this is something that you're kind of shooting in the dark and you're hoping to get a good picture. And if you don't, I mean, we might be making tubes of toothpaste where we probably make, thousands. We might be making, yachts where we make like 10. You just don't know. You just got to kind of trial and error a little bit here. So we're just going to choose zoom, fit, and see what our graph looks like. Okay. Make sure. Yeah. Okay. So I can't really see. I know what the graph is going to look like, right? This is a quadratic equation. And so I'm definitely not seeing that curve, that maximum. So I'm guessing that this is way too small. We're going to go ahead and make this something bigger. So something like maybe 500. We'll try that. Again, don't get frustrated if you don't pick the right window the first time. It is a process with a little bit of trial and error. Okay, so much better. So we're looking for the points where this is equal to 0. So again, I can't see both. There's one over here, but if I go a little further, I'm going to find another one. So again, I want to go ahead and adjust this further out. So I'm going to go with something like maybe 800. Again, it's not an exact science. You just want to make it further to the right. So you pick something bigger, and then we choose our zoom fit. And now we can see both points where this graph crosses the x-axis. That's what we're looking for. So calculator is going to find these for us. If we just do second trace, we want the 0 option here. Okay, so we want to take our cursor. We want to scroll it over until we're definitely to the left of that first point. So we're definitely to the left now. Then we'll scroll over somewhere to the right and hit enter. And then we'll hit enter one more time for our guess. So our first answer here is 30 units is where we break even. And then we'll do the same thing again, choose the 0 option. This time we want to scroll over. Definitely to the left. So we'll hit enter there. Then we'll scroll over past that point. Enter one more time for our guess, and then 600. So we'll break even if we produce 60 units or if we produce 600 units of this particular product. Okay, so can't stress this enough. That process that you see me going through where I have to adjust my window over and over again is an expected process. It's something you'll have to do on any of these application problems. The more information they give you, if they told us what kind of product we're producing, we can maybe use our real world experience and intuition to kind of help us out. But they didn't really give us any of that here. So it's just kind of a matter of trial and error. Don't get frustrated if you don't get the window right the first time. Expected part of the process. Okay, so hopefully that's helpful to get you off to a good start for this section. Please don't hesitate to contact me if you have any questions at all.